In this video we're going to take a look at the chemistry involved in the cracking of long-chained alkanes. An alkane is a carbon and hydrogen compound where the carbon is linked via single covalent bonds and has the general formula CnH2n plus 2, where n is an integer. Our source of long-chained alkanes here is liquid paraffin. Cracking is a process that breaks down these long chains into smaller chains and results in the formation of an ethene molecule, C double bond C, an unsaturated alkene. Ethene itself has the formula C2H4. To get the reaction to work, we simply need to heat up some of the long-chained alkane, the liquid paraffin, in the presence of a catalyst and collect the gases that are produced. Now the gas that's produced is mainly going to be ethene. You will also get some condensation into the trough of water of unreacted alkane, as well as of course the smaller alkanes that have been produced in the cracking process itself. And we can test for ethene gas. Ethene has the double bond, which makes it testable using bromine water and potassium manganate 7, potassium permanganate. If we're using potassium manganate 7, what we're looking for is a color change from purple to colorless when a few drops of acidified, so we've added some sulfuric acid to the potassium permanganate, when the acidified potassium manganate 7 comes into contact with a double bond. In the reaction with the double bond, two alcohol groups, two OH groups, attach to either side of where the double bond used to be. The diol produced, ethane 1,2-diol, or ethylene glycol, as its name is on the antifreeze bottles, is colorless. When we add bromine to a double bond, we would expect the color of the bromine to disappear. However, bromine itself is too poisonous to use, so we use bromine water. Bromine water has a few drops of bromine in water and it gives an orange coloration. Now bizarrely, it's not the bromine in the water that reacts to become colorless when it comes into contact with a double bond. It's the HOBr molecule that's also present. Removing the HOBr molecule causes any remaining bromine in the solution to make more HOBr, which again is removed. It's an equilibrium process that's been adjusted. So eventually the few drops of bromine water become colorless. If you use too much bromine water or too much potassium manganate 7, of course, you may not notice the change. Ethene is also inflammable. All hydrocarbons tend to be inflammable, so it will burn well in air. If it gives a blue flame, of course, it's complete combustion. If it gives a yellow flame, it's incomplete combustion.